Hello, everyone. My name is Bing Bing. So now I'm going to show you how we solve question number 5, homework 2. So on this question, we are given that the customer flow at a grocery store can be viewed as a Poisson process, and the equation for the probability of the number of the customer arrives in 0 minutes to t minutes is equals to e to the negative lambda t times lambda t to the k's power divided by the k factorial. We are also given that the probability that at least one customer will arrive in 2 minutes is equal to 0.3. So for part 1, the question is find the lambda. So in order to find the lambda, we know that we are given that the probability in 2 minutes, at least one customer will arrive is equal to 0.3. So we know that no customer will arrive in 2 minutes is 0.7, which means we 1 minus 0.3 is equal to the probability that no customer will come in 2 minutes. And then we plug in the equation that given from the question. So no customer arrives in 2 minutes is equal to e to the negative 2 lambda times 2t over 0 factorial is equal to, we simplify the equation and we get e to the negative 2 lambda, and is equal to 0.7, and then we solve for lambda, which is equal to 0.178. For question number 2, we are required to find the probability that in 3 minutes no customer will come. So we also plug in the equation that e to the negative 3 times lambda times 3t to the 0 power over 0 factorial. We simplify the equation and we get e to the negative 3 lambda equals to e to the negative 3 times 0.178, which is solved by the first part, and then we get 0.586. This is the probability that no customer will come in 3 minutes. Question part 3, we are required to find that in 10 minutes at least 2 customer will come. So the probability that in 10 minutes at least 2 customer will come is equal to 1 minus in 10 minutes at most 1 customer will come. So we plug in the equation, which is 1 minus e to the negative lambda t times lambda t to the 0 power over 0 factorial plus e to the negative lambda t times lambda t to the 1 power over 1 factorial. And we simplify the equation and we get 1 minus e to the negative 1.78 times 1 plus 1.78, and we get 0.531. This is the probability that in 10 minutes at least 2 customer will come. On question part 4, we are required to find in 1 minute that exactly 1 customer will arrive, and we plug in the equation e to the negative lambda times lambda to the 1's power, that's over 1 factorial. So 1 is the time t, and then we simplify the equation. We get lambda e to the negative lambda, and lambda is equal to 0.178, which is solved by the part 1, and then we finally get 0.149 is the probability that in 1 minute exactly one customer will arrive.